Welcome to another explainer. Right off the bat, think about the word chemistry for a second. What pops into your head? Probably boring, complex equations, right? Or dusty textbooks. But honestly, if you think chemistry is just a bunch of abstract rules you have to memorize, you just haven't been looking at the universe's building blocks the right way.
Today, we're flipping the script completely. We're going to look at the foundational elements of our universe through a totally different lens, basically as a dynamic superhero team. Think of this as the periodic Avengers, first assembly. We're going to take those complex chemical properties, map them onto action-packed traits, and see exactly how these elements are actively saving, sustaining, and building your world, literally every single second.
Okay, let's just quickly run through today's mission briefing so you know exactly who we're meeting. First up, we've got hydrogen, the ancient. Then, carbon, the architect. Number 3 is nitrogen, the protector. And finally, rounding out the team, oxygen, the sustainer.
But before we actually meet the individuals on this roster, you really need to understand the battlefield they're operating on. The physical reality all around you, it's not some quiet, boring library. It's a sprawling, chaotic action scene. Right now, at a microscopic level, elements are literally slamming into each other. They bond, they react, they oxidize and catalyze. I'm talking molecular explosions and high-energy exchanges happening constantly in the air you're breathing and in the cells of your body right now. This is their stage.
Let's jump into Section 1, starting with the very first element on the roster, hydrogen, the ancient.
Now, looking at hydrogen's basic atomic stats, it's wild because they actually double as a legendary origin story and an incredibly agile combat style. It has an atomic weight of just 1.008. That makes it the absolute lightest element in existence, giving it unmatched, almost spider-like agility. And how does it move? Well, it swings into action on glowing HH covalent bonds. See, in nature, hydrogen hates being alone. It always pairs up, sharing electrons to form this incredibly stable, dynamic duo.
And here's the crazy part. Despite being element number 1, the absolute smallest and simplest of the whole bunch, its cosmic footprint is massive. It is the most abundant element in the entire universe, period. It's literally the primary fuel for stars, making up roughly 75% of all normal matter. So, if hydrogen could speak directly to us, its voice would echo from the literal dawn of time, saying, "I am older than stars themselves." And it's entirely true. It formed in the immediate aftermath of the Big Bang, way before galaxies even existed. It's the primordial hero that set the stage for the whole shebang.
Moving right along to Section 2, let's see how we build the foundation of life with carbon, the architect.
If hydrogen is our agile acrobat, carbon steps onto the scene like a high-tech billionaire decked out in a state-of-the-art mechanical suit. Sure, its atomic weight is 12.011, but its true superpower is its structure. Carbon wears invincible, high-tech elemental armor made of a graphene hexagonal lattice. For context, that's one of the strongest, thinnest materials known to physics. And to top it all off, a cape shimmering with a diamond crystal structure. It's the exact same element, just a completely different, ultra-hard molecular arrangement.
And this specific chemical structure isn't just some diagram to memorize for a test. It is the pulsing power source driving our architect. Picture an Iron Man-style glowing chest reactor. For carbon, this is the benzene ring, or C6H6. It's a beautifully stable hexagonal ring of 6 carbon atoms, acting as the ultimate foundational building block for just countless vital chemical reactions.
Over 10 million. Just let that sink in for a second. That massive number is the sheer amount of known compounds that carbon forms. Because carbon has 4 valence electrons, it acts like a universal connector piece in a giant modular set. It can bond with itself and other elements to build endless chains, rings, and complex branches. Talk about absolute unmatched versatility.
And that wild versatility is exactly why carbon can make this incredibly bold claim. I am the backbone of all organic life. Listen, it is no exaggeration to say that without this hero, organic existence as we know it simply wouldn't assemble. Every single cell in your body, every plant outside, every living creature, all of it completely relies on carbon's architectural genius.
All right, next up on the agenda is a serious heavy hitter who basically controls the skies above us. Section 3, nitrogen, the protector.
Nitrogen is absolutely our cosmic warrior, sitting there with an atomic weight of 14.007. It doesn't just float around passively, it dominates.
Picture a powerhouse wielding a weapon of immense structural integrity, the N2 triple bond hammer, while summoning crackling nitrogen plasma lightning bolts. To really appreciate the protector, you've got to understand its weapon of choice, the triple bond. Here, two nitrogen atoms lock together by sharing 3 pairs of electrons. Once you understand this incredibly dense triple bond, you see exactly why nitrogen's power is so notoriously hard to break. It makes nitrogen gas incredibly stable and mostly unreactive. It's essentially a dense, protective shield that requires immense energy, like a literal lightning strike in our atmosphere, just to split it apart.
To truly grasp the scale of this protection, wrap your head around this. A staggering 78% of every single breath you take belongs to this element. Nitrogen actually dilutes the much more reactive oxygen, which keeps our atmosphere perfectly stable and prevents the entire planet from turning into a highly combustible powder keg. It is silently protecting us every single second of the day.
And finally, we arrive at the vital hero glowing with a blue, life-giving aura. Section 4. Oxygen, the sustainer. Let's check out oxygen's core stats. This right here is the absolute engine of biology. Packing 8 protons and 8 neutrons with an atomic weight just shy of 16, it arms itself with the ultimate equipment for our survival, the O2 molecule shield. But instead of deflecting physical blows, it deflects cellular death. It's the crucial element our cells use to burn fuel and create the energy that quite literally powers human consciousness itself.
Which brings us to a really stark reminder from oxygen itself. You take me for granted, every single breath. And honestly, it's true, isn't it? We never really stop to think about those O2 molecules seamlessly crossing our lung membranes, binding to hemoglobin, and rushing through our bloodstream to sustain our organs. It's this relentless, entirely unthanked hero, just operating quietly in the background of our whole existence.
So, stepping back from these individual profiles for a second, I really want you to change how you view the whole picture. The periodic table isn't just a rigid, boring chart on a classroom wall. It's a sprawling cityscape. Those element blocks, they're towering skyscrapers in a dynamic, explosive metropolis of physical reality. Each element is a totally unique character with its own strengths, weaknesses, and powers, constantly interacting to write the ultimate comic book story, which is the story of our universe.
Which perfectly brings us to our conclusion. Chemistry isn't boring. You just haven't met the right elements. I really hope this explainer has totally shifted your perspective today. The next time you take a deep breath of the sustainer or walk on the architectural marvels built by carbon, try to remember the heroes working tirelessly behind the scenes. So what do you think? Are you ready to look at the universe's building blocks in a completely different, heroic light? Because this periodic assembly is happening right now, all around you. Keep learning, keep questioning, and I'll see you in the next explainer.